What is up, everybody? This is the Algebra 2 Test 1.1 review. I'm telling you, folks, if you listen to this review and you do this review, your tests are going to be super duper easy. Alright, so let's check this mug out. Looking at question number 1. It says, what is the range of the following function? What is the range of the following function? Pause to do work. Alright, we're back. Let's see how you did. First thing I'm going to look at is that, man, that says range. I know range is always from the bottom to the top of the graph. The RBT, what up? So, if I'm looking at the bottom of the graph, then I'm definitely going to the bottom of the graph, which is right here. So that number is -4. Now, started from the bottom, now we're here. What? What number is that? That is to 0. So, my graph is from -4 to 0. So let's look at my answer choices. Some of those answer choices automatically cancel out. So if you chose A and you chose D, wah wah, you are wrong, folks. But that's all right because you were looking at the domain. Just remember, range is always from the bottom to the top. Bottom to the top. So now that we're starting at the bottom, I try to see, does it ever touch the graph? And bam, closed circle, plus it hits right here. So remember, if I'm looking at range or domain and range and it touches, then I use a bracket. So that automatically tells me my answer. But let's go ahead and look at the 0. I come up here, it does touch right there. Even though that's a closed circle, it touches right here. Therefore, that also gets a bracket. So I look at my answer choices, and you were the big baller shot caller if you chose C. Now remember, this isn't going to be the answer tomorrow, but if you can do this problem, then you can do this problem on the test tomorrow. So, range is bottom to top. Bottom to top, yo. Alright, let's look at the next problem. Problem number 2. Given the following graph, write the domain and range of the function to the right. This is the time to pause if you're trying to get work shown in class. Alright, we're back. It says, given the following graph, write the domain and range of the function. First thing I'm going to look at is my domain. Now, when I like to see domain, it's always left to right. Left to right. So I start over here to the left, and I look at that number. That's 1, 2, 3, 4. So I know my domain is starting at -4, and it goes on forever. So that's going all the way to the right. So I know that has to be infinity. So automatically, just looking at my answer choices, domain, B and C automatically cancel out. Now, since if I go up and it is a closed circle, that does mean I have to include the -4, so it's a bracket. And since we know, man, you can never touch infinity, infinity always has a brace, therefore, or parenthesis, therefore, A and D is our possible answers. But let's look at the range. If you remember from the last problem, range, you always look from the bottom to the top, the RBT. The bottom of the graph is actually right here. So that number looks like it's the number 2. And if you notice in A and D, it is the number 2. And then to top. But that arrow, even though it doesn't look like it, it's going to keep going up and up and up forever. So that's going to have an infinity. Now, did I touch 2? If I go across, BAM! It's a closed circle, you know what I'm saying? So yes, I do touch 2, so there's my bracket. And can we ever touch infinity? Aw, nah, dog. So for real, though. So my range is touching the 2, but never touching infinity. Therefore, A cancels out, and my answer is D. So if you got that, you are 2 for 2. I really hope you are. This is super duper easy because you work hard, folks. If you have any trouble, just go back and rewind this mug. Let's go to number 3. Number 3, it says, which of the following is a 0 on the graph? This is the time to pause to give it a shot. Okay, we're back. Which of the following is a 0 on the graph? Now, you got to be careful because you got to know what zeros stand for. You know what I'm saying? A 0 is always an x-intercept, intercept. It could be the word solution. It could be the word root. If you remember back in Algebra 1, zeros, x-intercepts, solutions, and roots always meant the exact same thing. So I'm going to go look at my graph, and I'm only going to focus on the x-axis. Here's the x-axis. So I've got this number here. Boom, 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 boom. Let me put it make it a little bigger. All right. Bam, right there, and right there. So I've actually got 3 spots, yo. 3 spots. So I'm looking at, one of the answers is -3. Come over here. None of them are -3, so that's not the one we're looking at. Let's change color, make this mug a little easier. This next one looks like it was at -1, but I think it was -1 point something, so we're still not there. But if I look at this number, that's perfect, right on 2, okay? So we had, I believe, -3, and it was like -1.2 and 2. The only number that is definitely matched up is the 2, okay? So hopefully you got that answer, because if you did, you're freaking awesome, because this is an easy problem 0. Just figure out which one matches. Don't look at the y-intercept. No, 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 no. That is not a 0, yo. So whatever the answer is, just make sure it's an x-intercept for a 0 on the test. Going on to number 4, for sure, for sure. All right, number 4 says, list the transformations from the original function to the function 6 f of x plus 3. This is the time to pause and see who can do it. All right, we're back, and now, first off, I know that 6 is on the outside. Guys, if it's on the outside of the parentheses, it's always doing something vertically, okay? This looks kind of funky. If it's on the inside, it always does something horizontally. Horizontal, blah, 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 blah. Now, if it's vertical, it changes the y. If it's horizontal, it changes the x. And if you remember, vertical, or y, is range. X is always domain. Don't forget that. So let's check it out. The 6 is on the outside, so it has a vertical change to the y. So I'm looking here, vertical stretch by 6, check. Vertical stretch by 6. It just so happens these all have a vertical stretch by 6. So I can't cancel that out. What's going to change my answer is going to be right here. Now, you've got to be careful. If you want to write this down in your notes, when it has an x plus, you're going to move to the left, okay? Think of Beyonce, to the left, plus always makes it move to the left. And if it's x minus, you take a guess. You got to move to the right, yo. People always get this mixed up because they think plus is to the right. No. And if you want to think about it this way, inside the parentheses, you do the opposite. And if you have a number line, you know you have a number line 0, 1, and -1. Do the opposite from the inside. So it says plus, so I'm thinking to the right because that's where all my positive numbers are, but it's wrong. You go to the left, to the left. So let's look at this mug. It says plus 3, so automatically I'm thinking to the left, so I know it has to move to the left. So let's look at our answer choices. This says move up, womp womp. Move to the right, womp womp. Move to the left, check. Whoop, check. Move down, womp womp. So the only ones that we have checks by both of them is C. It's a horizontal translation. Oh, look, and I said horizontal up in this mug. Horizontal to the left, 3. Now, if it had -3, you'd go to the right 3. I guarantee you people are going to mess that up, but it's so easy. Just do the opposite. Plus means left, minus means right. Say it. Plus means left, minus means right. What? Plus means what? Minus means what? Don't mess that up, man. Just do the opposite on the inside. Number 5. Check this one out. Let's see if you can do this one. How does the following transformation, x minus 2 squared minus 4, change the domain of the function if f of x equals x squared? All right. This is the time to pause and give everybody a shot. Okay, we are back. Let's see how you did here. Well, it says domain. Domain automatically means x, and I know x is always inside the parentheses. So when I look at this mug, I'm looking at right here. So how does it change? Well, I just went over this in problem number 4. When it's a minus, which way do we go? To the right is correct. Right how far? 2. So let's see. A says there's no change. Womp womp. Right 2, check. But let's check the other answers. Left, nope. Down, nope. Look at that. So a minus means to the right. A minus means to the right. Don't mess that up, yo. Don't mess that up. Because a minus means to the right if it's on the inside of the parentheses. Now, just for playing around, does anybody know what this change did? Oh, it's on the outside, so it has a vertical change, and it's negative, so that means you go down 4. So that means down 4, and this means to the right 2. Okay? You don't mess that up, man. You can do this, yo. Minus means to the right. A plus means to the left, okay? Only if it's on the inside. All right, next problem. Number 6. All right, number 6. What's the domain of an absolute value parent function? Well, domain, again, I'm thinking about the x's. And so we know a parent function goes all the way to the left. It goes all the way to the right. And when I'm thinking about domain, I'm thinking about left to right because that's where the x value or x-axis values are. So the graph is going all the way to the left. It's going all the way to the right. Therefore, it's going all the way to negative infinity. It's going all the way to positive infinity. And can we touch infinity? No, you cannot touch infinity. So therefore, you better have parentheses, not the brackets. So now that I have my parentheses, I just match it up my answer. Oh, that's super duper easy. A. All right. Now, if you're really good, what's the range? Let's just talk about the range real quick. If the range is bottom to top, let's see. Well, the bottom of the graph, that's 0. The top of the graph goes on forever, ever to positive infinity. Does it touch 0? Yes. Can you touch infinity? No. So there's the range of the parent function and the domain of the parent function we just found. All right? Super duper easy, man, because y'all working hard. Number 7, we're almost done here. Let's give this one a shot. Label the absolute value parent function below with range, vertex, max and min, y-intercept, and 0. Whoa, a lot to do here. So I'll go ahead and pause it and give everybody a chance to do it. Okay, we're back. Let's see. First off, talk about the range. Now, you probably can't tell here, but this goes on forever. So anytime I think range, I'm thinking range is from the bottom to the top. The RBT, what? The bottom of the graph is here, so that's 0. The top of the graph goes on forever, so it's positive infinity. We can't touch infinity, but we sure can touch 0, so there's my range. Check. The vertex is the very middle point, and so I go in right here. It's that point right there. Let's see, can I make that point a little bit bigger there? Point. That's the vertex. So let's go ahead and label that mug as the vertex. Now, check. Max or min? Does this graph have a maximum or a minimum? And it just so happens that this is the point we're talking about. Therefore, it is at the bottom of the graph. So what's that called? That's called a minimum for show. If the graph was going down, it'd have a maximum. All right, so that's checked. The y-intercept, OMG, it just so happens that it's the exact same spot as all this stuff right up in here. So the y-intercept is 0, 0. 0, 0, which is at the origin. Check. And do we have a 0? Now, if you remember earlier, we said what was a 0? A 0 is always the x-intercept, right? So we'll write that mug up in there. X-intercept is also right here, 0, 0. So sometimes the y-intercept and the x-intercept are the exact same thing because it touches the origin. So we got to check up in here. So, big question is, the vertex of a parent function is also known as a what? A minimum, because that's the lowest point on the graph. Hint, hint. All right, lowest point on the graph is the minimum. Okay. All right, this problem's pretty simple problem up in here. It says you're given f of x equals the absolute value of x. Fill out the table to represent for f of x. So we're going to give you a chance to pause it. Okay, we're back. Let's see. I told you the x values, which are the domain values, and now we want to know what for f of x is. Now, if you remember back in Algebra 1, f of x always means y. So if I'm doing for f of x, that means I'm doing 4 times y. Right? That's right. So let's check it out. First off, I need some y values. So I'm going to go right here, x and y. If I got -2, -1, 0, 1, and 2, if I plug in -2, the absolute value of -2 is 2. Absolute value of 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2, right? So that's the absolute value. But now I've got to multiply 4 times y. So 4 times 2 is 8. 4 times 1 is 4. 4 times 0 is 0. 4 times 1 is 4. And 4 times 2 is 8. So this would be my table that I would have that would match this type of problem. So 4f of x would be 4f of x right up in here. And that's how you do it. So tomorrow on the test, you're going to simply plug in your number, or do the absolute value, and then multiply by whatever it says. Okay, pretty simple there. And you're going to match the table. And if it doesn't work, don't pick that table. All right? Moving on. So if that one was easy, this one should be just as easy. If f of x equals absolute value of x, fill out the table to represent f of x plus 2. This is the time to pause. Okay, we're back. So I'm going to just draw my little simple table here, x and y. We know it's -2, 1, 0, 1, and 2. This time we're going to add 2 to f of x. And if you don't like using f of x, you can always put y, because y and f of x are the exact same thing. So let's give this a shot. First off, the absolute value of -2 is 2. Absolute value of 1, 0, 1, and 2. But remember, we've got to do something to every single number. So let's try it. 2 plus 2. Let's switch colors up in here. 2 plus 2 is 4. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. So this would be the table that represents f of x plus 2. Should be very simple. You just take the absolute value of this mug and then do to the y what it says. The problem beforehand, it said multiply. This problem says add. You just simply, if you can multiply and add, folks, this is one of the easiest problems that you can do. All right, so I'm hooking you up with how to do the test. Hopefully you're paying attention and learning up in this mug. And the last question I'm going to help you with today is this one. Using the graph below, write the domain for the function using interval notation. This is the time to pause. Okay, we're back. All right, now remember, domain is always left to right. Range is always the bottom to the top. That helps me every single time. I've been teaching for a long time, and I still label LRBT. So left to right. So I'm going to go over here, and it looks like the arrow's going on forever, and the arrow's going on forever. So I know my left side's going to negative infinity. Right side's going to positive infinity. And since I can't touch infinity, guess what? I put my little parentheses. Now, it just so happens that this says -2, which we said nope. Those two cancel out. And this one has a bracket on it. You can't touch infinity, so that's gone. So guess what? My answer has to be D. But because we know that, okay, I'm just going to make sure that my range is correct. So let's check out the range real quick. Now the range is bottom to top. Remember, bottom to top. So the bottom of the graph, OMG, is -2. Okay? And the top of the graph goes on forever. So that's going to be infinity. Now, since I can go across and BAM! Hit the graph, then it touches the graph. And can we ever touch infinity? No way, Jose. So therefore, I put my little parenthesis there, and it just so happens -2 with the bracket and infinity with the parenthesis. So there's my answer. Folks, domain and range is super easy. If you know to go left and right, bottom to top, you will easily knock that out. I want to wish you luck on your test. This has been Big Mac, and good luck. Knock it out of the park, folks. I know you're going to work hard and study hard. Peace out.